This is one of the inboard rear brake discs off my 1981 Lotus Esprit, the S3 normally aspirated version, and these are meant to be 10mm thick. This one is down to a fraction over 8, so it's fairly heavily worn, and these are available but relatively expensive. I think they work out at about £80 each. And from a bit of research, I found that it's possible to modify these discs, which are from the rear of a Mk3 Mondeo, which I believe cost me just over £30 the pair. So there is enough meat in there to just about get the 3 holes in. I don't need to bore the centre out to this size, but I may do so anyway. But one thing I had to determine was the PCD of this bolt pattern. So that's in fact why it's clamped to the bed of the mill, is using pins through these holes and lining up on the slots. I got these holes very close to being parallel to the table axis, and I then used a coaxial indicator to find the centre of this hole and this hole using the DRO, and then used the hand little chart in the Zeus book. So here in the Zeus book is a handy chart giving XY positions for various bolt patterns based on the PCD, but I can just run the conversion in reverse. So for the 3-hole pattern, I simply divide the distance I measured between the holes by the C conversion factor you can see there to get the PCD, which gave me a value of 122mm. This is the setup I've come up with to drill the new 122mm PCD 3-bolt pattern in this Ford Mondeo rear disc to replace this very worn original from my 1981 Lotus Esprit. So I've got a super spacer on the bed of the mill, and I've adjusted the chuck to run true, and I've centered the spindle up on the axis of the super spacer, and then I set the disc so that this hole is accurately at the 12 o'clock position, so that, and is above one of the jaws, so I've got a clear area to drill through here, and then I can just index it 120 degrees. I've got it set on 0 now to do the 2 remaining holes. So I've got a spotting drill set up in it. I'll then go through with a pilot drill, an undersized drill, and the final 12mm. index 120 degrees. And repeat the process. Now these holes are very close to existing ones in the disc, but there is just enough metal to mean that it is held securely on the hub. One final index. $240. Now I might see if I can go and find a countersink. So we can see we've got our new pattern in here. The way other people have done it is they bisect just the one hole, but this I think actually gives more meat either side. I may skim out the ID or I may not, haven't decided.